Hello everyone, welcome to Programming Knowledge. So I again welcome you all to Programming Knowledge. So in today's tutorial, we are going to cover with 2D dynamic programming. So basically, what I mean by 2D dynamic programming is tabulation. Today we are going to cover with 2D dynamic programming, that is tabulation. The basic difference between the 1D and 2D is like in the 1D we used to use array, but in the 2D we are going to use matrix, and this is known as tabulation. While the concept in 1D, that is linear, that concept is known as memoization. So today we are going to concept with the tabulation. So let's get started with today's tutorial. So the first problem I am going to cover is unique paths. So the basic, I'll explain this problem. So like in this problem, what I have a 3 cross 2 matrix. So I'll write down this matrix. Suppose just for example, this is my matrix. Uh, just for the example, uh, 0 0 0 and 0 0 0. So I am standing at the top left. So basically I have to reach from top left to right bottom. So I have to reach from top left to right bottom, and I can only move in right direction and down direction. So I have to I have to calculate calculate the number of unique combinations, or what you say, permutations, anything, number of unique ways to reach there. So just for an example, so I'm standing at top left and I have to reach at the right bottom, and I can only move in right and down direction. I have to calculate the number of unique ways to reach there. So for this test case I have three, like I move right, right, and then down. I move to down, so this is down, then right, I come, here goes down, then right, then down, I come here, then from here I move right and again right. So these are the three ways. So let's implement this in our Python code. So for this, we take a matrix, generate a matrix, and then we approach the problem. So let's solve this. So just for the case, I'll take t is equal to int input number of test cases for I in range t, and I'll take two parameters, r comma c is equal to map int comma input dot split. Then what I'm going to do, I'll create a matrix dp is equal to 0 star c for I in range r. So this will generate me an empty matrix, and now I'll make a logic behind to construct this 2D dynamic programming logic. So basically what I need to do for I in range R, for j in range C, if I is equal to 0 or j is equal to 0, so here I can move only horizontally, that is right, and vertically, that is down. Then dp of ij will have a value, else I'll calculate a value of dp of ij. Okay, so basically now I have two values. So one is move only horizontally and vertically, that is if I is equal to 0 or j is equal to 0, else I have a choice. Because if you are in the first row or in the first column, so you can only move in one direction, that is in column you can move vertically down, and in the row you can move horizontally right. Though I have a choice that like here i can move I can move only one direction, only in one direction, either horizontally or either vertically. So dp of ij becomes 1, else I have a choice, move down or right. So dp of ij will have a value. So dp of ij will have a choice. So the choice would be I'll move. I can come. If I move down, so I'll have the value of the my upward value, or dp of I comma j minus 1. So j minus 1, that is if I move right, so I will have a value of j minus 1, and if I come down I will have a value of I minus 1. Then simply print dp of minus 1 comma minus 1. Simply this would give you the value of the last index. Okay, so let's run our program, and I'll give two values, 3 comma 2. So I'll give two test cases, 3 comma 2. So this gives me the first value of 3. Another test case I am having here is 7 and 3. So let me run this 7 and 3. Perfect. So this completes our one program, that is the unique path. So let's do the another one. So this is another one. So what I'm telling you, that this problem is also similar to that one. So I have to move. I'm standing at the top left and I have to reach at the right bottom. I can move only in right and down direction. But now calculate the minimum cost. Calculate the minimum cost to reach there. The first brute force solution that comes in our mind is that we generate all the paths and then we calculate the cost for each part, but that's a brute force solution. The optimal solution would be done using the dynamic programming. So let's do this using dynamic programming. So what I'll do, I'll copy this template because this is very much the same. And now what I'm going to do, uh, since I would take an input matrix, so I'll take dp is equal to empty list. Okay, first I'll remove this. Yeah, perfect. The dp is an empty matrix for I in range r. So I'll take a list dp dot append list map comma int comma input dot split. So this would I would fill my matrix, initial matrix. Now I have to go with the cost. So that's very interesting. For I in range 1 comma r, so this is the one. So and the similar we do for j in range 1 comma c, and the next we do for I in range r, for j in range c, and then in the end we print dp of minus 1 comma minus 1. So we have got our template for this question to solve. This is very much similar to the last one. So first calculate the min cost for row wise. Okay, so when I have a min cost for the row wise, so you can see dp of I comma 0 plus equal to dp of I minus 1 comma 0. Because I told you that if you are in the first row and the first column, you have only one choice to move, that is either horizontally or vertically depending on the row and the column. So the second one would also apply for the same. So here let's do this, dp of 0 comma j plus equal to dp of 0 comma j minus 1. Okay, so move min cost for column wise, because here you can see we can have not much of the choice. Either you can move horizontally or horizontal or vertical depending on the first row or in the first column. But now I have a choice to take minimum. So dp of ij is equal to minimum of dp of I minus 1 comma j comma dp of I comma j minus 1. So perfectly fine. So just choice to take minimum either vertical, because either right or down. So and this in this one we were we had a choice to uh, we had a choice. So we were making only one choice, either we make minimum for row wise and minimum for column wise, because we can only make in one direction, the first row and the first column. But when we get out of that first row and the first column, then we have a choice. So let's run our test cases. So this is the path, and the path we are going to take is 13111. So that is the minimum cost we are going to take. So let's run this test case. Invalid syntax. Okay, let me debug for I in range R. Yeah, I had an error in here. Yes. So this should be DP. Yes, perfectly fine. Okay, I had to give a test case value as well. So I'll run again. I'll give one test case, and the matrix R comma C value will be 3, and this is my matrix. Okay, I'm having some issue. Let me check please. Yeah. So hello, welcome back to your call. I had an error. Like first error was that I had to take the indexing from one comma R and one comma C, and then I had to also get the I have to add the value. So I had to put a plus symbol here. So after putting that plus symbol, I can now reach my desired value. So let's run our test case, and now I'll show you. I'll copy the test case. Yeah, perfectly. So I'll get the value as 7. Okay, so you can also trace that matrix also, how did we reach that value, and this is the way you will get. So like one, so like in the same way you can see, we have 1, then 3, that becomes 4, then we have value becomes 5, then 6, and then 7, we reach that value. Perfectly fine. So thank you guys, thank you so much. So I'll catch you in the next video.